March 17th, 1943. Atlantic Ocean, 420 miles southeast of Newfoundland. Kapitänleutnant Werner Henke stood in the conning tower of U-515, his Zeiss binoculars scanning the horizon through morning fog that clung to the wave tops like smoke. He had been hunting in these waters for 11 days, part of Wolf Pack Raubgraf, 21 submarines positioned across the convoy routes between Halifax and Liverpool. The mathematics should have been simple. His intelligence briefing in Lorient had been explicit. German submarines were sinking Allied merchant vessels at a rate of approximately 600,000 tons per month. British and American shipyards could replace perhaps 300,000 tons monthly using traditional construction methods. The gap was widening. Britain was starving. America's supplies were drowning before they reached European ports. Yet something had changed in recent months, something Henke couldn't reconcile with the arithmetic of victory his commanders preached. The convoys kept coming. More ships, always more ships. Where traditional maritime logic said the Allies should be desperately rationing their remaining hulls, conserving vessels for only the most critical missions, instead Henke watched convoys that seemed to grow larger with each patrol. Through the grey water ahead, shapes materialized. Convoy HX-22. 9. 43 merchant ships, arranged in 9 columns, each column stretching nearly 2 miles from lead vessel to trailing ship. Destroyers prowled the flanks. A corvette zigzagged ahead, hunting submarines with ASDIC pings that Henke's soundman could hear even at this distance. But it was the cargo ships that held Henke's attention. Not the individual vessels, but their sheer number. 43 ships, when his intelligence had suggested the British were so desperate for hulls, they were pressing ancient coal burners and obsolete tramp steamers into service. These weren't antiques. These were new vessels, many clearly fresh from shipyards, their paint still clean, their hulls riding properly in the water rather than showing the patched, weathered appearance of ships that had survived multiple Atlantic crossings. Henke lowered his binoculars and descended into the control room, where his first watch officer was plotting firing solutions. "How many ships did we sink on last patrol?" Henke asked, though he knew the answer precisely. 7 confirmed, Herr Kaleu, 3 tankers, 4 cargo vessels, approximately 42,000 tons. And the patrol before that? 9 ships, 51,000 tons. Henke studied the chart spread across the navigation table, the marked positions of submarine attacks, convoy routes, the growing tally of Allied tonnage sent to the ocean floor. The numbers were impressive, devastating, even. Yet the convoys kept coming, kept growing, as if the Allies possessed some inexhaustible reserve of ships that multiplied faster than torpedoes could sink them. "Prepare tubes 1 through 4, Henke ordered. "We will attack from the starboard flank at dawn." What Kapitänleutnant Henke couldn't know, what no German naval intelligence officer had yet comprehended, was that 3,000 miles away in Richmond, California, an industrial revolution was rewriting the mathematics of maritime warfare. The arithmetic that said German submarines would strangle Allied supply lines had encountered a variable that traditional naval strategists had never considered possible. Ships were no longer being built. They were being manufactured. The transformation had begun not in response to U-boat successes, but in anticipation of them. On December 7th, 1941, when Japanese aircraft struck Pearl Harbor and threw America into total war, the United States Maritime Commission understood with brutal clarity what was coming. The Battle of the Atlantic would be won or lost not through superior naval tactics or advanced anti-submarine technology, but through industrial capacity. Could American and British shipyards build vessels faster than German submarines could sink them? Admiral Harold Stark, Chief of Naval Operations, received the initial projections in late December 1941. The numbers were catastrophic. German U-boats were operating with near impunity in the Atlantic. British shipyards, already strained after 2 years of war, could build approximately 30 cargo ships monthly using conventional methods. Each ship required between 200 and 240 days from keel laying to delivery. American shipyards, while larger and more numerous, were geared toward commercial construction at peacetime rates. The combined Allied shipbuilding capacity using traditional approaches might replace 400,000 tons of shipping monthly. German submarines were demonstrating they could sink double that tonnage or more once they received sufficient boats to maintain constant patrol density. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The solution emerged from the most unlikely source. Henry Kaiser, a construction magnate who had never built a ship, had signed his first maritime commission contract in December 1940. His proposal had been audacious to the point of absurdity. He would build cargo vessels using assembly line techniques borrowed from automobile manufacturing, welding instead of riveting, prefabricated sections instead of piece-by-piece construction, unskilled workers trained in weeks rather than craftsmen apprenticed for years. By March 1943, when Henke stalked convoy HX-229, Kaiser's 7 shipyards were completing Liberty ships at an average rate of 42 days from keel to delivery. But that average concealed something far more extraordinary. The fastest yards, particularly Richmond Yard No. 2 and Portland's Oregon Shipbuilding, were completing vessels in under 10 days. The record, set by SS Robert E. Peary in November 1942, stood at 4 days and 15 hours from keel laying to launch. The implications were staggering. A traditional shipyard, working at maximum capacity, might complete one vessel every 7 months. Kaiser's Richmond facility, operating 7 parallel building ways, was launching a completed Liberty ship every single day. 1 yard, 7 building ways. A new ship every 24 hours. German naval intelligence initially dismissed the reports as Allied propaganda. The numbers were impossible. Ships couldn't be built that quickly. The steel alone required weeks to cut, form, and rivet into hull sections. Complex machinery, engines, boilers, propulsion systems, electrical networks. These components took months to install and test. The idea that complete cargo vessels were sliding down building ways every day violated everything that maritime engineers understood about ship construction. Yet the convoys kept growing. By spring 1943, U-boat commanders were reporting target densities that shouldn't exist. Werner Henke wasn't alone in his confusion. Kapitänleutnant Siegfried von Forstner, commanding U-402, sent a terse message to BDU, the U-boat command headquarters in Paris, after a patrol in April 1943. Sank 5 vessels totaling 32,000 tons. Observed convoy of 61 ships 2 days later. Impossible to reconcile losses with observed merchant fleet size. Request clarification on Allied construction capacity. The response from Admiral Karl Dönitz's staff was equally terse and reflected the growing anxiety at U-boat headquarters. Allied shipbuilding capacity estimated at 600,000 tons monthly. Current sinking rate must exceed 700,000 tons to achieve tonnage war objectives, increase attack frequency. But the estimate was catastrophically wrong. By April 1943, American shipyards alone were launching over 1.4 million tons of new shipping monthly. Kaiser's facilities accounted for nearly 40% of that production. The mathematics of the tonnage war had inverted. For every ship German submarines sent to the bottom, American yards were launching 3 replacements. The secret lay in fundamental reimagining of what shipbuilding meant. Traditional maritime construction treated each vessel as a unique craft project. Master shipwrights supervised teams of skilled workers who fabricated components on site, fitted them individually, and assembled ships through sequential processes that had remained essentially unchanged since wooden sailing ships gave way to steel steamers. Kaiser had thrown out every assumption. His Richmond yards didn't build ships. They assembled them from prefabricated components manufactured in parallel across multiple facilities. While one crew welded hull plates in Building Way 3. Another crew 20 yards away was installing a complete engine assembly that had been built, tested, and mounted on its foundation structure in a separate workshop. Cargo holds arrived as finished rectangular boxes, complete with internal bracing and hatch coamings, ready to be lifted by massive cranes and positioned in the hull. The bow section, comprising 50 or more individual pieces traditionally fabricated sequentially, arrived at the building way as a complete unit. Anchor, windlass installed. Chain locker equipped. Forward crew quarters finished with bunks, lockers, and ventilation. The stern section included completed steering gear, shaft alley, and aft accommodations. What had been 6 months of sequential construction became 6 days of parallel assembly, but the real revolution was in the workforce. Traditional shipyards recruited from maritime communities where skills passed from father to son across generations. A master, riveter, had typically spent 4 years as an apprentice, another 6 years as a journeyman, before achieving the skill level to lead a crew. Kaiser advertised in newspapers across America, offering wages 20% above standard industrial rates and promising to train anyone willing to work. The simplification of complex tasks into repeated simple operations proved devastatingly effective. Traditional welders spent years learning comprehensive skills, every type of joint, every material, every position. Kaiser's instructors taught specific techniques for specific tasks in approximately 2 weeks. A worker didn't need to know how to weld everything. She needed to know how to weld vertical seams on bulkheads, which she would do 800 times during a ship's construction. By spring 1943, Kaiser employed over 190,000 workers across his 7 yards. Of these, fewer than 5,000 had any maritime experience before 1941. Rest were farmers, housewives, clerks, labourers, people who had never seen a ship under construction until they reported for their first shift. Yet they were building vessels that crossed the Atlantic, carried millions of tons of cargo, and withstood the brutal conditions of wartime convoy operations. The prefabrication strategy reached its ultimate expression in Richmond Yard No. 2. The facility didn't resemble a traditional shipyard at all. Instead of massive gantry cranes looming over longitudinal building ways, Richmond featured 7 parallel ways, surrounded by open areas for component fabrication. Railroad tracks crisscrossed the yard, moving steel sections weighing up to 150 tons. Overhead cranes capable of lifting entire ship sections stood every 100 feet. Walking through Richmond during a shift change in April 1943 would have assaulted the senses with industrial intensity that seemed chaotic but was precisely choreographed. The shriek of electric arc welders, thousands of them operating simultaneously across the facility. The thunderous impact of drop hammers shaping steel plates, the grinding scream of cutting torches, the mechanical rumble of locomotives moving steel sections, the sharp percussion of pneumatic tools driving bolts through structural members. Over 10,000 workers occupied the yard during peak shifts. Women in welding leathers, their faces hidden behind protective hoods, ran beads along seams that would hold Atlantic waves. Crane operators positioned sections with precision measured in fractions of inches, guiding tons of steel into alignment with hand signals and radio communication. Inspectors crawled through partially assembled hulls, checking welds, verifying dimensions, marking defects for immediate correction. The scale of parallel production overwhelmed traditional comprehension. On a single day, April 15th, 1943, Richmond Yard No. 2 had 7 Liberty ships in, various stages of assembly simultaneously. Hull 8-3 had just received its keel, the first structural element touching the building way. Hull 8-4, 2 ways over, was receiving its engine installation, a 140-ton triple-expansion steam power plant being lowered into the completed engine room by a massive crane. Hull 8-5 was receiving its deck houses, the superstructure sections being positioned and welded. Hull 8-6 was undergoing final fitting, with workers installing electrical systems, painting interior spaces, mounting defensive armaments. Hull 8-7 stood complete, awaiting launch. Hull 8-8 was sliding down the ways into San Francisco Bay, completing its journey from keel to water. Hull 8-9 had been launched the previous day and was tied to the fitting-out pier for final systems testing. Each hull represented roughly 470,000 worker hours of labour, compressed into an average construction time that had fallen to 30 days by spring 1943. That was the yard average. The fastest construction times were far shorter. SS Jonathan Harrington, built on Way 4, required 17 days from keel to delivery. SS William Clark, built on Way 7, needed 19 days. The competition between Kaiser's 7 yards had become public spectacle through late 1942 and early 1943. His son Edgar, managing the Oregon Shipbuilding Corporation in Portland, and Clay Bedford, overseeing Richmond, engaged in an informal race to see whose facility could build ships faster. Newspapers published construction times like sports scores. Workers took pride in beating records, pushing themselves through extra shifts to shave hours off previous marks. Vice Admiral Howard Vickery, vice chairman of the Maritime Commission, eventually ordered the speed competitions halted, declaring them stunt demonstrations that distracted from actual production goals. But the competition had served Kaiser's purpose. Workers across all 7 yards now believed that extraordinary speed was not merely possible but expected. The psychology of achievement had been transformed. What seemed impossible in 1941 had become routine by 1943. But for German U-boat commanders hunting in the North Atlantic, the implications of this industrial transformation remained incomprehensible throughout 1943. The arithmetic they had been taught, the tonnage war calculations that said Allied shipping capacity was finite and exhaustible, kept colliding with the evidence appearing on their periscope horizons. Kapitänleutnant Henke's attack on convoy HX-229 demonstrated both the tactical effectiveness of U-boat operations and the strategic futility they couldn't yet recognize. U-515 approached the convoy's starboard flank in the pre-dawn darkness of March 18, 1943. Henke selected targets carefully, identifying a tanker in column 6 and a large freighter in column 7. At 0430 hours, he fired a spread of 4 torpedoes from tubes 1 through 4. The range was 1,200 meters, an easy shot for an experienced commander. 2 torpedoes struck the tanker amidships, breaking her keel. She settled by the stern, burning furiously, her crew abandoning ship into lifeboats. The freighter took 1 hit forward, the explosion tearing open her bow. She began settling immediately, but slowly enough that her crew had time for orderly evacuation. Henke dove deep, running beneath the convoy as depth charges from the escort destroyers churned the water above him. Standard procedure: strike, dive, escape the immediate counterattack, then surface well astern of the convoy to pursue and attack again after nightfall. U-515 had performed this dance dozens of times. The escorts were competent, but not exceptional. Henke expected to sink at least 2 more ships before the convoy reached the air cover range from Iceland. By dawn, on March 19th, U-515 surfaced 30 miles astern of the convoy's last position. Henke spent the day shadowing, sending position reports to Bidau so other Wolf Pack Raubgraf boats could converge for coordinated night attacks. Standard doctrine developed through 3 years of Atlantic operations overwhelmed the escorts with multiple simultaneous threats, forcing them to defend everywhere while submarines struck from darkness. That night, 5 U-boats attacked convoy HX-229. The battle raged for 6 hours. Star shells burst overhead, illuminating the sea in harsh white light. Escort destroyers raced between columns, dropping depth charges, firing at surfaced submarines with deck guns. U-boats maneuvered between merchant ships, firing torpedoes at point-blank range before diving to escape counterattacks. By dawn on March 20th, 8 merchant ships had been sunk, 4 tankers, 3 freighters, 1 ammunition ship that exploded so violently the blast was felt by submarines 8 miles away. Approximately 63,000 tons of Allied shipping sent to the bottom. For Wolf Pack Raubgraf, it was a successful operation. 8 ships sunk, 2 escorts damaged, all submarines escaped. The convoy was devastated, reduced from 43 vessels to 35. Henke composed his patrol report during the submerged transit back to France, documenting tonnage calculations, tactical observations, recommendations for future operations. His success was undeniable, yet one line in his report, almost an aside, revealed the cognitive dissonance growing among experienced U-boat commanders. Despite sinking 8 vessels, Convoy appeared to maintain cohesion and proceed on schedule. Remaining ships showed no indication of delay or diversion. This contradicts expectations regarding convoy disruption from major losses. The report reached BDU on March 23, 1943. Admiral Dönitz's operations staff analysed it alongside dozens of other patrol reports arriving that week. The cumulative picture was simultaneously encouraging and disturbing. U-boats were achieving impressive tactical successes. Monthly sinking totals exceeded 600,000 tons. Individual commanders were demonstrating exceptional skill and aggressiveness. Yet the Allied convoy system wasn't collapsing. Convoys that lost 8, 10, even 12 ships continued to their destinations and offloaded cargo as scheduled. The merchant fleet wasn't shrinking, it was growing. Where British authorities should have been desperately husbanding their remaining hulls, rationing cargo space, prioritizing only the most critical supplies, instead they seemed to be expanding convoy schedules and increasing cargo loads. The explanation, had German intelligence possessed accurate information, would have shattered every assumption about maritime logistics and industrial capacity. Between January and March 1943, American shipyards delivered 347 new merchant vessels, totaling over 4 million tons. Kaiser's 7 yards alone accounted for 161 ships, nearly half the total American production. Those 8 ships Henke sank from convoy HX-2-9 represented approximately 63,000 tons. During the 72 hours that convoy battle raged, American shipyards launched replacements totaling 140,000 tons. For every ship U-515 sent to the bottom, American yards launched more than 2 replacements. The Allies weren't losing the tonnage war. They were winning it by margins that made German submarine successes tactically impressive but strategically irrelevant. Admiral Dönitz understood that something had changed, though he lacked accurate intelligence to comprehend the scale. His strategic assessments through spring and summer 1943 reflected growing frustration, with arithmetic that refused to balance according to pre-war calculations. In a conference with Hitler on May 10, 1943, Dönitz presented updated projections that attempted to reconcile observed convoy densities with reported sinking statistics. "We are sinking Allied shipping at rates exceeding our most optimistic pre-war estimates," Dönitz reported. Yet the enemy's merchant fleet appears to be expanding rather than contracting. I can only conclude that Allied construction capacity has been dramatically underestimated in our intelligence assessments. We may need to achieve sinking rates of 1 million tons monthly to inflict sufficient losses. Hitler, characteristically, responded with demands for increased U-boat production and more aggressive tactics. But the fundamental problem wasn't tactics or even submarine numbers. The problem was that German naval planning had failed to anticipate that shipbuilding itself could be revolutionized. Traditional maritime construction doctrine said ships required months to build. That doctrine had remained unchanged for over a century. Kaiser had made it obsolete in less than 2 years. The April 1943 production statistics from Richmond Yard No. 2 illustrated the magnitude of transformation. The yard completed 42 Liberty ships that month, an average of 1.4 ships daily. Construction time averaged 28 days from keel laying to delivery. The fastest ship, SS Joseph Medill, required just 16 days. The slowest, delayed by steel delivery issues, took 39 days. Each of those 42 ships displaced 14,245 tons fully loaded and could carry 10,800 tons of cargo. The monthly output from Richmond alone, approximately 600,000 tons of new shipping, exceeded the total sinking capacity of the entire U-boat fleet operating in the Atlantic, 1 yard. 7 building ways, outproducing hundreds of submarines and thousands of trained crew. The workforce that achieved this production represented a complete reputation of traditional maritime labor practices. Of Richmond's 92,000 workers in April 1943, approximately 27% were women. African American workers numbered in the thousands, employed in skilled positions, including welding, crane operation, and supervisory roles, a level of workplace integration remarkable for 1940s America. The youngest workers were 18, fresh from high school, learning to weld or operate complicated machinery in training programs lasting 2 to 4 weeks. The oldest workers were in their 60s and 70s, retired farmers and clerks who had answered Kaiser's recruitment advertisements. The average worker had been employed in the shipyards for less than 18 months. Many had never held industrial jobs before the war. Yet these amateur shipbuilders were defeating the Kriegsmarine through sheer productive capacity. Every Liberty ship they completed represented another convoy vessel, another cargo delivery, another increment in the mathematical advantage that made German submarine warfare strategically futile, regardless of tactical successes. The daily rhythm of Richmond Yard No. 2 during peak production in mid-1943 followed patterns that would have seemed insane to traditional maritime engineers. 0600 hours, day shift began. 10,000 workers flooded through the gates, picking up assignment cards that directed them to specific building ways, specific tasks. Welders collected their equipment and moved to marked positions on partially assembled hulls. Crane operators climbed into their cabs and received instruction sheets detailing which prefabricated sections needed positioning. By 0630 hours, the yard transformed into coordinated chaos. Thousands of welding arcs flared simultaneously, so bright that looking across the facility without protective eyewear caused immediate pain. The sound was overwhelming, a continuous industrial roar punctuated by the sharp reports of pneumatic tools and the grinding shriek of cutting torches. On Building Way 3, Hull 9-2 was receiving its engine installation. The triple expansion power plant, manufactured by Joshua Hendy Iron Works in Sunnyvale, had been completely assembled and tested at the factory. It arrived at Richmond mounted on its foundation structure, a complete unit weighing 140 tons. The crane operator positioned it above the engine room opening, lowering it slowly while workers below guided it into precise alignment with mounting bolts that had been pre-positioned during hull construction. The entire operation required 4 hours from crane attachment to final bolt torque. In a traditional shipyard, engine installation was a weeks-long process. Components arrived separately and were assembled inside the engine room, a cramped workspace that limited crew size and tool access. Kaiser's approach was faster, simpler, and produced better results because the engine had been assembled in optimal factory conditions and tested before installation. On Building Way 5, Hull 9-4 was receiving its bow section. The massive component, weighing approximately 80 tons, had been completely fabricated in the prefab area over the previous week. It included finished crew quarters, anchor windlass, chain locker, collision bulkheads, and all internal piping and electrical systems. The crane lifted it from the staging area and positioned it against the forward hull section, where welders immediately began connecting the pieces. Traditional shipbuilding would have constructed the bow on the ways, piece by piece, over weeks. Kaiser's method completed the bow in a separate workshop, then installed it in hours. The difference wasn't just speed. The prefabrication shop provided better working conditions, easier access for quality control, and the ability to correct problems before components reached the building way. By 1400 hours, day shift was reaching its midpoint. Inspectors moved through partially assembled hulls, checking welds with magnetic particle equipment that revealed microscopic cracks invisible to visual examination. Any defect discovered received immediate attention. The defective weld was ground out and re-welded before adjacent work proceeded. Kaiser's quality control philosophy was simple: fix problems immediately. Never allow defective work to be built over or concealed by subsequent construction. At 1800 hours, day shift ended. Night shift began at 1830 hours, overlapping for 30 minutes to ensure continuity. The yard never stopped. 3 shifts, 24-hour operations, 7 days per week, Building ways that stood empty were building ways that weren't launching ships. Every hour of idle time represented lost production, cargo that wouldn't reach Britain, supplies that wouldn't support operations. The psychological impact on workers was profound. They understood, through relentless company communication and newsreel films shown in facility cafeterias, that their work directly affected the war's outcome. Every ship they completed was another vessel carrying ammunition to British forces, food to starving populations, aircraft to airfields, tanks to armoured divisions. Production wasn't abstract. It was visceral, immediate, measured in completed ships sliding down ways into San Francisco Bay. On May 1st, 1943, Richmond Yard No. 2 achieved a milestone that seemed impossible even to those who had witnessed the previous 18 months of accelerating production. The yard launched its 200th Liberty ship, 200 complete cargo vessels in 17 months of operation. A traditional shipyard might have completed 20 vessels in the same period. Richmond had produced 10 times that number with a workforce that had barely existed 2 years earlier. But the 200th ship represented more than accumulated production. It represented the culmination of systematic refinement, the product of learning curves that had compressed construction processes to their theoretical limits. Every ship built had taught lessons that improved the next. Welding sequences were optimized. Crane movements were choreographed. Material flows were streamlined. Worker training was perfected. By May 1943, Richmond Yard No. 2 had transformed shipbuilding into something approaching automotive assembly. Not identical, ships were vastly more complex than cars, but similar in philosophy. Standardized components, specialized workers, parallel production, continuous flow. The result was construction speeds that defied traditional maritime engineering comprehension. The breakthrough that enabled 72-hour construction came not from a single innovation, but from the convergence, multiple refinements implemented simultaneously. Clay Bedford, overseeing Richmond operations, had been studying production statistics obsessively through late 1942 and early 1943. The average construction time of 28 days represented impressive achievement, but Bedford believed the theoretical limit was far lower. His analysis identified bottlenecks. Certain operations consumed disproportionate time despite adequate worker assignment. Material deliveries occasionally delayed work, even when components were available elsewhere in the facility. Quality inspection sometimes required rework that added days to schedules. Each bottleneck was addressable, but addressing all of them simultaneously required coordination across every aspect of yard operations. Bedford proposed an experiment. One hull, constructed using maximum prefabrication, optimal scheduling, and unlimited resource priority. Every component would be pre-built, pre-tested, and staged before assembly began. The best workers would be assigned. Inspections would be continuous rather than sequential, catching defects immediately. Materials would be pre-positioned. No delays would be tolerated. The target was 72 hours from keel laying to launch, 3 days. It seemed absurd even to workers who had grown accustomed to extraordinary speeds. The fastest previous construction, the Robert E. Peary's 4 days and 15 hours, had been a carefully orchestrated demonstration using pre-built components and around-the-clock effort. Bedford was proposing to cut that record by a third as standard procedure rather than special effort. Vice Admiral Vickery, visiting Richmond in late May 1943, expressed polite skepticism. Kaiser has proven repeatedly that conventional wisdom about shipbuilding limits was wrong, Vickery acknowledged, but there are physical constraints. Steel requires time to weld. Components require time to install. Systems require time to test. I'm not convinced 72 hours provides sufficient time for quality construction. Bedford's response was characteristic. We won't know the limits until we test them. Give me authorization to try. Vickery approved on condition that the attempt not disrupt regular production schedules and that the vessel undergo the most rigorous inspection ever applied to a Liberty ship before. Acceptance. If the 72-hour ship showed any quality deficiencies, The experiment would be declared a failure regardless of completion speed. Hull 208 was selected for the record attempt. The ship would be named SS Frederick Funston after a United States Army general. Construction would begin on June 1st, 1943, at precisely 0800 hours. Every major component was pre-built during the last week of May. The bow section, completely assembled and equipped, underwent final inspection on May 30th. The stern section, including installed steering gear and shaft alley, was positioned on railroad cars ready for crane lifting. 4 cargo hold sections, each a massive box structure of welded steel, stood on trailers. The engine, manufactured by Joshua Hendy Iron Works, had been running on test stands for 48 hours to verify proper operation. It was already mounted on its foundation structure, complete with all auxiliary equipment, pumps, condensers, fuel systems, electrical connections. The deckhouse sections were finished down to painted interior bulkheads and installed fixtures. Gun mounts were pre-assembled, anchor windlass tested, lifeboats inspected and equipped. What traditional shipyards fabricated sequentially over months, Richmond had built in parallel workshops over weeks. The assembly on the building way would simply connect pre-finished components that were individually complete and tested. It was the ultimate expression of prefabrication philosophy, the logical endpoint of Kaiser's manufacturing approach applied to maritime construction. June 1st, 1943, 0800 hours. The keel sections for Hull 208 touched Building Way 4. Unlike traditional keels that were positioned and then built upon sequentially, this keel arrived as a complete longitudinal structure with bottom plates already welded, frames already attached, internal piping already installed. Crane operators positioned it precisely using laser surveying equipment, borrowed technology from civil engineering that had never been applied to shipbuilding before. By 0900 hours, just 60 minutes into construction, the bottom of the ship was complete. Keel, bottom plates, bilge sections, all welded and inspected. Workers moved across the surface, connecting electrical grounds for the welding that would follow, positioning hydraulic jacks that would support subsequent lifts. At 0930 hours, the first cargo hold section arrived. The massive steel box, 30 feet high, 40 feet wide, 60 feet long, weighed approximately 120 tons. 2 cranes working in coordination lifted it from the trailer and positioned it over the keel. Workers below guided it down using tag lines, aligning bolt holes with precision. By 1000 hours, the hold was bolted in place, and welders were connecting it permanently to the bottom structure. The second hold section arrived at 1030 hours, the third at 1100 hours, the fourth at 1130 hours. By noon, 6 hours into construction, the entire cargo capacity of the ship was structurally complete. 4 holds installed, aligned, and welded. In traditional construction, building one hold took weeks. Richmond installed 4 in a morning. The engine installation began at 1300 hours. The Joshua Hendy power plant, all 140 tons of it, was lifted by the yard's largest crane. The operator, a woman named Margaret Whitley, who had been driving cranes for 18 months, positioned the massive assembly with extraordinary delicacy. The engine descended into the engine room opening, guided by 12 workers stationed around the perimeter with alignment tools. At 1345 hours, 90 minutes after the lift began, the engine rested on its mounting bolts. Welders immediately began connecting it to the hull structure, while other workers connected shaft alley sections that would transmit power to the propeller. By 1600 hours, 8 hours into construction, the ship had its heart. The engine was installed, connected, and undergoing preliminary checks. The bow and stern sections arrived simultaneously at 1700 hours. 2 massive cranes, positioned at either end of the building way, lifted both sections together. It was precisely choreographed industrial ballet, thousands of tons of steel moving through air, positioning with inch-level accuracy. Workers had rehearsed the movements during the previous week, timing every step, eliminating uncertainty. By 1900 hours, 11 hours into construction, the ship had its complete hull, bow connected, stern connected. The vessel stretched 441 feet from stem to stern post, its form recognizable as a ship rather than a collection of components. But it was far from complete. Night shift arrived at 1930 hours. Not a replacement crew, but an augmentation. Day shift workers remained on station, working alongside night shift personnel. Bedford had authorized unlimited overtime, promising bonuses for completed work and penalties for nothing. The financial incentive was unnecessary. Workers understood they were attempting something historic. Money motivated less than pride, and the desire to prove that the impossible was merely difficult. Through the night, work continued under floodlights that turned the building way into harsh white brilliance. Deck house sections were positioned and welded. Gun mounts were installed, 20mm Oerlikon, anti-aircraft weapons and 3-inch deck guns for surface defense. Electrical cables were pulled through conduits. Plumbing was connected, ventilation systems were tested. Interior spaces received finishing work. Crew quarters were equipped with bunks and lockers. The galley received its stoves and refrigeration equipment. The wheelhouse, the nerve center of the ship, was fitted with steering gear, engine telegraph, compass, radio equipment, navigation instruments. Every system was tested as it was installed, eliminating the sequential testing that traditionally occurred after construction completion. Quality inspectors moved through the ship continuously, checking every weld, every connection, every system. They didn't wait for sections to be complete before inspection. They inspected as work progressed, catching problems immediately. Defects discovered at 2200 hours were corrected by 2300 hours. Nothing was allowed to proceed until underlying work passed inspection. By 0200 hours on June 2nd, 18 hours into construction, the ship was structurally complete, every major component installed, every system connected. Inspectors began their final reviews, checking against acceptance criteria that had been established before construction began. No shortcuts had been taken. No quality standards had been relaxed. The ship had to meet every specification that applied to Liberty ships built over months. At 0600 hours, June 2nd, 22 hours into construction, the ship passed final inspection. Every system tested, every weld verified, every component approved. SS Frederick Funston was complete, except for the painting and minor fitting work that traditionally occurred after launch. But Bedford wasn't satisfied with 22 hours. He wanted 72 hours because that would demonstrate that 3-day construction was repeatable, not dependent on pushing workers beyond sustainable limits. Continued finishing work through June 2nd and into June 3rd. Interior paint, exterior paint, deck equipment adjustments, loading of ship stores, food, water, fuel, spare parts. At 0800 hours on June 4th, exactly 72 hours after the keel touched the building way, SS Frederick Funston was ready for launch. The ship sat on the ways, complete in every respect, awaiting only the release of restraining blocks and the slide into San Francisco Bay. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The launch occurred at 0830 hours with Admiral Vickery present, along with Maritime Commission officials, competing shipyard representatives, and journalists from newspapers and newsreel services across America. Many expected to witness either a compromised vessel that looked complete but lacked functionality, or a propaganda stunt that wouldn't withstand scrutiny. What they saw was a fully operational Liberty ship that underwent the most aggressive acceptance testing ever applied to a merchant vessel. Over the following week, Frederick Funston was subjected to trials that would have been considered abusive under normal circumstances. The engine was run at maximum power for 48 continuous hours. Every system was stressed to its rated limits. Hull inspectors used X-ray equipment to examine critical welds, looking for any defect that might indicate rushed work. The ship passed every test. On June 12, 1943, SS Frederick Funston was officially accepted by the Maritime Commission and delivered for service. She would complete 37 Atlantic crossings during the war, survive multiple severe storms, carry over 400,000 tons of cargo, and remain in service until 1963, 20 years after her 72-hour construction. The implications of 72-hour construction were profound and immediate. Richmond Yard No. 2 had demonstrated that the theoretical limit for Liberty ship construction was roughly 3 days, rather than the months traditional maritime engineers had considered necessary. More importantly, the 72-hour construction had been achieved not through superhuman effort or unsustainable worker exploitation, but through systematic optimization of processes that could be repeated. By July 1943, Richmond was routinely completing ships in 5 to 7 days using the refined procedures developed during the Funston construction. Other Kaiser yards adopted the same approaches. Portland's Oregon Shipbuilding completed a vessel in 6 days. The Kaiser yards in Vancouver, Washington, achieved 5-day construction. The average construction time across all American Liberty shipyards, which had been 42 days in April, fell to 28 days by September 1943. But for German U-boat commanders, the Zeiss T5th, implications remained invisible behind intelligence failures and cognitive resistance to accepting that the arithmetic of maritime warfare had fundamentally changed. Kapitänleutnant Werner Henke returned to Lorient on June 28, 1943, after his 6th war patrol. He had sunk 11 ships totaling 72,000 tons during the patrol, his most successful operation. Yet his patrol report, declassified decades later, revealed the psychological confusion that permeated U-boat operations by mid-1943. Convoy density appears unchanged despite reported losses across all operational zones. Multiple convoys observed with 60-plus vessels. Intelligence briefings suggest Allied shipbuilding cannot replace current loss rates, yet observed evidence contradicts this assessment. Request clarification regarding enemy maritime construction capacity. The clarification never came because German naval intelligence lacked sources capable of penetrating American industrial operations. They knew Kaiser's yards existed. They had intercepted reports about accelerated construction, but they dismissed the reports as propaganda, inflated numbers intended to demoralize U-boat crews. The idea that a single shipyard could launch a completed vessel daily seemed physically impossible. Admiral Dönitz, addressing U-boat commanders at Lorient in July 1943, acknowledged the discrepancy between predicted and observed results, but attributed it to temporary factors. Allied convoy systems have improved, he explained. Air coverage has expanded. Escorts have become more effective. We are achieving impressive sinking totals, but the enemy has adapted his defensive measures. We must adapt our tactics accordingly. What Dönitz couldn't acknowledge, perhaps couldn't conceive, was that tactics were irrelevant. The Allies had solved the Battle of the Atlantic not through superior anti-submarine warfare, though that helped, but through industrial capacity that made German submarine successes strategically meaningless. By mid-1943, American shipyards were launching approximately 4 million tons of new merchant shipping monthly. German submarines were sinking approximately 500,000 tons monthly. The gap was devastating. For every ship U-boats sent to the bottom, American yards launched 8 replacements. Even if U-boat effectiveness doubled, which was impossible given improving Allied defenses, they couldn't sink ships faster than Kaiser's workers could build them. The tonnage war was over. Germany had lost. They simply didn't know it yet. The mathematics became undeniable by autumn 1943. In September, German submarines sank 29 Allied merchant ships, totaling 156,000 tons. In the same month, American shipyards alone, not counting British construction, launched 342 new vessels, totaling 4.8 million tons. The ratio was 30-1. 30 new ships launched for every ship sunk. British shipping losses, which had peaked at over 700,000 tons monthly in 1942, fell to 200,000 tons monthly by late 1943, not because U-boats had become less effective, but because there were exponentially more ships to attack. The Allied merchant fleet, which numbered approximately 3,000 vessels in January 1942, had grown to over 6,000 vessels by December 1943. The strategic implications extended beyond simple numbers. With shipping capacity exceeding requirements, the Allies could afford to operate vessels inefficiently. Ships could sail partially loaded if scheduling demanded it. Convoys could take longer, slower routes that reduced U-boat exposure, even if they increased transit time. Vessels could be retired from service for extended maintenance rather than running them to failure. The abundance of shipping eliminated constraints that had governed Allied logistics for the war's first 2 years. Operation Overlord, the invasion of Normandy in June 1944, illustrated the transformed maritime situation. The operation required 5,000 ships and landing craft to transport 156,000 troops plus their equipment, vehicles, supplies, and ammunition across the English Channel. A year earlier, assembling such an armada would have been impossible. It would have required stripping every other theatre of shipping, accepting massive risks in the Atlantic and Pacific. By June 1944, the invasion fleet was assembled without significant disruption to other operations. Atlantic convoys continued running on schedule. Pacific operations received adequate shipping. The Mediterranean remained supported. The surplus of available hulls meant Operation Overlord competed for ships, not against other military operations, but against routine commercial traffic. For German U-boat commanders, the Normandy invasion represented the final psychological break with pre-war doctrine. They had been taught that naval forces, particularly submarine forces, could interdict enemy logistics by sinking sufficient tonnage to make amphibious operations impossible. The Channel crossing, the most shipping-intensive operation in military history, should have been the ultimate target for U-boat interdiction. Yet German submarines, despite desperate attempts to attack the invasion fleet, were almost entirely ineffective. Not because U-boat tactics were flawed, but because the mass of shipping was simply too great. A handful of submarines attempting to stop 5,000 vessels was like trying to drain an ocean with buckets. Individual ships were sunk, but the vast majority crossed successfully, and the invasion proceeded on schedule. Kapitänleutnant Henke, promoted to corvette and capitaine and given command of a larger submarine by spring 1944, attacked Allied shipping off the Normandy coast in early June. His boat was detected by escort destroyers and subjected to a depth charge attack that lasted 7 hours. When U-515 finally surfaced, critically damaged and unable to dive, Henke surrendered his crew to the destroyer HMS Bulldog. In prisoner interrogation, conducted by Allied naval intelligence officers and documented in files declassified in the 1980s, Henke described his understanding of why Germany was losing the maritime war. His testimony revealed that even experienced U-boat commanders, despite mounting evidence, had never comprehended the scale of American shipbuilding. "We believed we were winning," Henke stated. "Every patrol, we sank ships, tankers, freighters, ammunition ships. The tactical results were excellent, but the convoys kept growing larger. More ships, always more ships. We assumed the British had reserves they were drawing down, accumulated shipping from their empire. It never occurred to us that the Americans were building vessels faster than we could sink them. That seemed impossible." The interrogator asked how many ships Henke estimated were required to support Allied operations. "Perhaps 3,000 merchant vessels," Henke replied. "No nation could maintain more than that simultaneously." The interrogator informed him that the Allied merchant fleet numbered over 7,000 vessels by June 1944 and was growing by approximately 200 ships monthly. Henke initially refused to believe the figure, insisting it must be propaganda. When shown production statistics and photographs of multiple Kaiser shipyards operating simultaneously, he fell silent for several minutes before responding. "If those figures are accurate, and I cannot believe they are, but if they were accurate, then U-boat operations were futile from the beginning. We were not fighting a naval war, we were fighting industrial capacity, and we never had any chance of success." That realization, coming from one of Germany's most successful U-boat commanders, captured the essential truth about the Battle of the Atlantic. Maritime warfare between 1939 and 1945 was decided not by tactical brilliance, advanced technology, or strategic genius, but by the productive capacity of American shipyards that transformed construction from a craft tradition into an industrial process. The Liberty Ship program ultimately produced 2,710 vessels between 1941 and 1945. Kaiser's 7 yards built 1,490 ships, over half the total American production. At peak efficiency in mid-1944, Kaiser yards were completing a new ship every 10 hours on average across all 7 facilities. Richmond Yard No. 2 alone completed over 500 vessels during the war, more ships than entire nations had built in peacetime decades. The human cost of this production was measured not in lives lost, though shipyard accidents killed several hundred workers during the war, but in transformed opportunities. The tens of thousands of women who learned welding, crane operation, and skilled trades carried those capabilities into peacetime careers. The African American workers who had been excluded from skilled industrial employment before the war established themselves in trades they would practice for decades. The economic impact rippled across American industry. The steel requirements for Liberty ship construction drove expansion of West Coast steel production. The machine tool industry, manufacturing the equipment that built the ships, grew exponentially. Supporting industries, transportation, housing, healthcare, all expanded to serve the shipyard workforce. Kaiser Permanente, the health maintenance organization that emerged from medical services provided to shipyard workers, became one of America's largest healthcare providers, serving over 12 million members by the early 21st century. The model of prepaid preventive care, pioneered in the shipyards, influenced American medical practice for generations. The technological innovations developed during Liberty ship construction influenced industries far beyond maritime applications. Welding techniques refined under wartime pressure became standard in structural steel construction, petroleum refining equipment, and pressure vessel manufacturing. Prefabrication approaches pioneered at Richmond influenced construction practices in housing, bridge building, and industrial facilities. But perhaps the most significant legacy was psychological rather than technical. Liberty ship construction proved that perceived industrial limits often reflect organizational constraints rather than physical impossibilities. Before Kaiser, maritime experts accepted that ships required months to build using traditional methods. Kaiser demonstrated that the traditional methods were the problem, not an unchangeable reality. The lesson applied far beyond shipbuilding. When industries face challenges that conventional wisdom claims impossible, the Liberty Ship program stands as evidence that revolutionary improvement requires questioning fundamental assumptions. Ordinary people, given training and opportunity, can achieve extraordinary results. Complex products can be manufactured quickly using systematized processes. Industries resistant to change can be transformed when necessity and innovation combine. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The Liberty ships are mostly gone now, scrapped decades ago or resting on ocean floors, but 3 survive as museum ships. SS John W. Brown, built in 1942, remains operational in Baltimore. SS Jeremiah O'Brien, also built in 1942, is preserved in San Francisco and actually sailed to Normandy in 1994 for the 50th anniversary of D-Day. SS Hellas Liberty serves as a museum ship in Greece. These survivors carry testimony to the revolution they represented, not just ships, but proof that industrial capacity, when properly organized and challenged, can accomplish what traditional wisdom claims impossible. Kapitänleutnant Werner Henke, interrogated as a prisoner of war, had been correct in his final assessment. Germany wasn't fighting a naval war, they were fighting American industrial capacity, concentrated in places like Richmond Yard No. 2, where ordinary workers achieved extraordinary production through systematic innovation and relentless optimization. The 72-hour construction time for SS Frederick Funston represented the ultimate expression of that capacity. Not a stunt or a propaganda demonstration, but a proof of concept that ships could be manufactured at speeds that obliterated traditional maritime construction doctrine. When Bedford's workers laid that keel on June 1st, 1943, and launched a completed vessel 3 days later, they weren't just building a ship, they were demolishing the arithmetic that German strategists had relied upon to win the Battle of the Atlantic. Admiral Dönitz, reflecting on the war in his memoirs published in the 1950s, acknowledged the fundamental miscalculation. "We underestimated American industrial capacity," he wrote. "Our calculations assumed traditional shipbuilding limitations. We never conceived that the Americans would revolutionize maritime construction itself. By the time we understood what was occurring, the tonnage war was already lost. We continued fighting because we were ordered to continue, but strategically, the outcome was determined by factors beyond our control. Those factors were forged in the shipyards of Richmond, Portland, and Baltimore, shaped by welders like Bessie Hamill, who questioned established procedures, organized by industrialists like Henry Kaiser, who refused to accept traditional limitations, built by thousands of workers who believed they could achieve the impossible and then proved it by launching ships faster than U-boats could sink them. The mathematics of maritime warfare had been rewritten, not through advanced weapons or brilliant tactics, but through industrial transformation that made German submarine successes tactically impressive but strategically irrelevant. Every 3 days, another Liberty ship slid into the water. Every week, 7 new vessels joined the fleet. Every month, 200 replacements overwhelmed whatever tonnage U-boats managed to sink. That was how American shipyards built Liberty ships in 72 hours and obliterated U-boat strategy forever. Not through superior technology or military genius, but through the revolutionary understanding that ships could be manufactured rather than crafted, that industrial capacity could expand beyond traditional limits, and that ordinary people could accomplish extraordinary results when properly trained, equipped, and challenged to attempt what experts claimed could not be done.